Section 4.7 is on transformations of quadratic graphs. The standard form of a quadratic function is what we've been looking at all along. That is y equals, or f of x equals, ax squared plus bx plus c. You can write this in another form called the vertex form of a quadratic function. And that's in the form y equals a times the quantity x minus h squared plus k. This is called vertex form because you can just look at it and find the vertex. hk is the vertex. X equals h is the axis of symmetry, and the letter A determines the shape and the direction in which the parabola opens. So let's take a look at a couple examples of writing a quadratic function, taking it from standard form into vertex form. So you'll notice, actually let me go back up here, you'll notice that the x minus h stuff is squared. So that means that what we need to do is complete the square and make part of this a perfect square trinomial. So in order to do that, I'm going to actually use some parentheses here to help me do that. And instead of, when we completed the square, we would have moved that 6 to the other side. Here I'm not going to do that. I'm just going to put it outside the parentheses. So I just took my quadratic term and my linear term and put those in parentheses, moved my constant term outside. Now I need to make what's in the parentheses a perfect square trinomial. So remember to do that, I take half of b and square it. So I'm going to add a 4 here. And normally what I would do is add a 4 to the other side of the equal sign. But actually I want to stay on the right side of the equal sign. So since I did a plus 4 here, I'm going to do a minus 4 here. Notice they cancel each other out, and I would get back to my original standard form of the equation. You would only do a plus 4 on each side if I was actually doing it over here, but I don't want it over there. I want that to stay y. So now I'm going to factor this trinomial, and that will factor into x plus 2 squared. Simplify those, that becomes a plus 2. And that's vertex form of this parabola. And it's called vertex form, remember, because I can just look at it and figure out what the vertex is. In the parentheses here, this is x minus h, so my h of my vertex is negative 2, and my k is 2. So looking at that, I know what the vertex is. Let's take a look at this one here. Y equals 2x squared minus 12x plus 17. So again, I'm going to, now this is a little tricky. I'm going to take my quadratic term and my linear term and complete the square, but remember I can't have, a can't be greater than 1. So I'm going to put the 2 outside the parentheses, and I'm going to factor a 2 out of my first two terms. So that's going to give me x squared minus 6x, and then plus 17. So notice what I did was I took my first two terms, factored out a, and left that in the parentheses. Didn't touch c, just put him outside the parentheses. So now let's complete the square. Half of negative 6 is negative 3, squared is 9. So I'm going to add a 9 here. Okay, but did I really add a 9? I didn't. What I really added was 9 times this 2 out here. I really added 18. So over here I need to subtract 18. Don't forget that if you have something outside the parentheses and you put something inside the parentheses, you have to multiply those. So my final form, now let's factor this trinomial. That's going to be x minus 3 squared minus 1. So what this says is my vertex is going to be 3, negative 1, and this 2 out front tells me that my graph is going to be a little bit narrower than the parent function. So here's a chart from your textbook, and actually we've kind of talked about this, I believe it was back in chapter 2, some of the transformations that we do on functions. Remember that we said if the number inside the parentheses, it's kind of the opposite of what you might think. Here's the standard the vertex form of a parabola, of a quadratic function, and notice it's an x minus h. Okay, so if h is a positive number, so if it would be like x minus 5, it's going to move to the right. If h is a negative number, which would make that x minus a negative, basically x plus a number, it's going to move to the left. K, the number outside, moves the function up or down. Up if k is positive, down if k is negative. If a is positive, it opens upward. We already knew that. If a is negative, it opens downward. If a is a number greater than 1, it's going to make the graph narrower, closer to the y-axis. So that would be this red parabola inside. And if a is a fraction between 0 and 1, it's going to make it wider, like this green parabola right here. So using that information, let's graph each function. So here I have y equals the quantity x minus 5 squared minus 2. Looking at this, since it's in vertex form, I can tell that the vertex is going to be 5, negative 2. Okay. I can also tell that because this is a minus a 5, this is going to be translated to the right 5 units. And the 2 outside means it's going to be translated down 2 units. So a couple ways you could do this. You could start with your basic, let's go ahead and do that. Why don't we start with our basic parent function, y equals x squared. And that's actually kind of easy to figure out here. Okay, so there's our parent function. I'll go ahead and label it y equals x squared. And now the one that we're going to have to graph here is basically moved to the right 5 units and down 2 units. So every point, I could do that with every point. To the right 2, to the right 5 and down 2. And let's see, to the right 5 and down 2. To the right 5 and down 2. Oops, sorry about that. And there's the function y equals x minus 5 squared minus 2, using a translation. And let's take a look at our last example here. Y equals 2x squared plus 5. This is not written in vertex form, but I think we can do that. We can go ahead and write this in vertex form. You'll notice that this does not have a linear term. There's no plain old x in this equation. So I would take the 2 out of the parentheses, and that would just give me x minus 0 squared plus 5. Looks a little crazy, but if I were to write it in vertex form, it would look like that. So my vertex is the point 0, 5. So there's no left or right translation, but this is going to be translated up 5. And the 2 out front means that it's going to be narrower. Okay, so I can start with, it's going to start up 5, so there's going to be my vertex 0, 5. Now the translating it or making it narrower, that's going to be a little complicated. I think I'm actually just going to make a table and get a few values here. So my vertex is 0, 5, and I'm going to do negative 1, negative 2, 1 and 2. And so when I put in negative 2 squared, that gives me 4. 4 times 2 is 8 plus 5 gives me 13. And I'm going to get the same thing for this. When I put a negative 1 in there, I get 1 times 2 is 2 plus 5 is 7. Okay, so let's go ahead and graph those points. 1, 7. And 2, 13 is going to be like up here somewhere. And you can see, I'll go ahead and do our parent graph kind of down here. It looks something like this. It is definitely wider. So you can see that the 2 out front does make it narrower. So in this section, we took a look at writing a quadratic function in vertex form, which really helps us to graph it. It makes it really easy to find the vertex, and reviewed some of the transformations of quadratic graphs.